Okay, hey guys, so like I promised, we're going to be doing some long division again in this section, but with polynomials, not integers. So just a reminder from the lesson we recently did with long division. If I'm dividing something like 315 divided by 4, just for example, if we're thinking of that with long division, my divisor goes on the outside of this division bar, 315 goes on the inside, my dividend. And then we started this by asking ourselves, how many times or how many whole times does 4 go into? And then since it doesn't go into 3, you would go out to the next digit. So how many times does 4 go into 31 evenly? Or 4 times what gets me close to 31 without going over? So 4 times 7 is 28, and that's going to be the closest I can get to it. So I put 7 up here. Then once I do have that 28, so 7 times 4 is 28, what's remaining of that? So you would subtract 28 from 31. We get 3. Then bring down the rest of the number, 5, and repeat the process until this number is smaller than 4. So again, so 4 times what is 35? That would be, the closest I can get to 35 would be 8. 4 times 8 is 32. What's left of 35 minus 32 is 3. And then we've got our remainder, our quotient, and that's the long division process, just a quick recap of that. So before we do long division of polynomials, I do want to remind you guys of that Polydoku. And I'm actually going to work through this first one using Polydoku and then have it over here to reference, because we're going to be thinking a lot of the same things, but with long division, we're just going to be arranging it differently. So with Polydoku, if I wanted to take P of X and divide it by D of X, what I would do is basically I want to know 2x plus 1 times what equals this. So that's the idea of Polydoku. 2x plus 1 is one dimension times what, so up here is what I want to know, is going to equal 6x cubed minus 9x squared plus 8x plus 1. So 2x times something, this 6x cubed is going to be my first starting point down here. 2x times what is 6x cubed? Well, that's going to be 3x squared. But if that's 3x squared and that's 1, then this is also 3x squared times 1. But in my original P of X here, I want negative 9x squared, and I have positive 3. So that means I'm going to have to take 12x squared away. That means 2x times what is negative 12x squared. So that would be negative 6x. But if that's negative 6x and that's 1, then this is also negative 6x. But I have positive 8 x's in my polynomial. So from negative 6 to get to positive 8, I would have to add 14 more x's back in. And then if that's 14x and 2x times something equals that, that would have to be 7 up here. 7 times 1, 7. But I wanted 1, so that means I need to subtract 6. And then I've got this whole polynomial in this area model, plus a little extra here. So this would be my remainder, r of x, and my quotient, q of x, is right here. So a quick recap of Polydoku, which is the strategy we used to divide polynomials in Math 3. So I'm going to leave this here so that you can see the connections as we work through the long division process of this. Polydoku is great, but it's not practical for all polynomial long division. So I do expect you, even though you can do a lot of these problems using Polydoku, there will be some that it's just not practical to arrange as an area anymore. And we're going to use the long division process. So you do still need to learn the long division. We'll set up the long division the same way that we did up here. So my divisor, 2x plus 1. And then I'm going to switch to green because it's easier to see. So 2x plus 1, and I am dividing that out of 6x cubed minus 9x squared plus 8x plus 1. So I'll move this for a second. So the first thing here, these hints for polynomial long division, both the dividend and the divisor should be written in descending powers, and missing powers should be represented by 0 times the variable. That means if I had 6x cubed here and it jumped to 8x, then I would need to put 0x squared. So you want to represent every power of x. This one I have x cubed squared to the first and then 1. So I've already done that here. Okay, so now we're going to continue with the long division, and we're focusing on the 2x. So just like we did here, I said, what do we need to multiply 2x by to get 6x cubed? It's the same thing. I'm focusing on this 2x first, and then the 1 is going to kind of just like fall into place as we go. So 2x times what? The leading term, no matter what, of your divisor. That's what you're focusing on. What do I multiply that by to get 6x cubed? Well, that's 3x squared. And then I'm just going to arrange that over my x squared term. And then we want to figure out, okay, if 2x times 3x squared is 6x cubed, then what's remaining of this polynomial that I still need to continue working through? So 3x squared, what you're going to do next is multiply that by this whole thing. So we're multiplying 3x squared by that whole thing. So 3x squared times 2x is 6x cubed. And then 3x squared times 1 is 3x squared, and it's positive. Then we're going to subtract that away from our original dividend and see what's remaining of that. So 6x cubed minus 6x cubed. So that's the goal here. We already took care of that right here. So what's remaining of my x squareds, it would be negative 9x squared minus, so that that minus gets distributed to the 3x squared. So it would be negative 12x squared. And that's how we got this negative 12x here, was because we had positive 3, but we needed negative 9, so we subtracted 12x. So that just happens here in the long division. Then we bring down the whole rest of the polynomial, so plus 8x plus 1. So we've just done like the first round, and then we just continue with that. So now I'm checking to see how many times 2x plus 1 goes into this polynomial. So but again, I'm focusing on the 2x, and then we'll figure out how the 1 affects it as we go. So 2x times what is negative 12x squared. So that would be negative 6, and then x times x is x squared. So negative 6x, and that's what we got here as well. 2x times what is negative 12x, negative 6x. And then once I have that negative 6x, then I multiply that by, again, this entire thing. So negative 6x times 2x is negative 12x squared, and negative 6x times 1 is negative 6x. And then we're going to take that away and see what's remaining. So I'm subtracting that whole thing. So negative 12x squared minus negative, that turns into a plus, which is 0x squared. That's what we wanted to happen. And then 8x minus negative 6x. So that's going to make that a positive 6x. And that's 14x. And again, that's how the same as this 14x. When we had negative 6x's, but we knew we needed 8, I added 14. So that's the 14. Bring down the rest of the polynomial, the plus 1, and continue the process until this degree, 14x, is less than the degree of our divisor. So 2x times what is 14x? That's 7, positive 7. Take the 7, multiply it by the 2x plus 1. So 7 times 2x is 14x. 7 times 1 is 7. Subtract it and figure out what's left. The x's get subtracted away, 0x, and 1 minus 7 is negative 6. And again, here's our 7 that we had at the very end, 7 times 1, and then the negative 6 is our leftover remainder. So our q of x, the quotient here, is at the top 3x squared minus 6x plus 7, just like we knew would happen from our Polydoku. And the remainder, r of x, is negative 6. So that long division process follows the same thinking process as integer long division. And it's doing a lot of the same things as our Polydoku. It's just arranged differently. Like I said, Polydoku, as representing these divisions as an area model, works a lot of the time, but you are expected to learn polynomial long division and do it that way as well. So let's look at another one just to get another repetition of this long division. Okay, this one I'm not going to do the Polynomial for. We're just going to jump right into the long division. Okay, so we're going to set up our divisor on the outside here, right small, because I think this one has kind of got several steps. Okay, and then, okay, so this one, as we're writing out, I want to go back up to this whole missing powers thing. If you're missing powers, so 6x to the 5th minus x to the 4th, and then it jumps to x. So I don't have an x cubed term, so we need to consider that, and I don't have an x squared term. So those are the missing powers that I need to represent in my dividend for the long division. So I would write 6x to the 5th minus x to the 4th plus 0x cubed plus 0x squared plus x plus 1. Okay, so that's going to help us stay organized with all of our different terms and powers. So we start, again, we focus on this 2x squared. And then this, whatever happens with this x will just fall into place as we go. So 2x squared times what is 6x to the 5th? Well, 2 times 3 is 6, and x squared times x cubed. So I'm going to put that over my x cubed term here. So 2 times 3 is 6, and x squared times x cubed is x to the 5th. Okay, so this is the first term of my quotient. Now I'm going to take that, multiply it by this whole thing. 6x cubed times 2x squared is 6x to the 5th. 3x cubed times x is 3x to the 4th. And that'll be positive. And then we want to figure out what is remaining of our dividend. So we're going to subtract that away. So the x to the 5th terms are gone, and I have negative x to the 4th minus, don't forget that minus distributes 3x. So negative 1x to the 4th minus 3, that's negative 4x to the 4th. And then from here, we're just bringing down everything. So bring down the whole rest of this. 0x cubed plus 0x squared plus x plus 1. Then we repeat the process. What do I multiply 2x squared by to get negative 4x to the 4th? So 2 times negative 2 is going to give me the negative 4, and x squared times x squared will give me the x to the 4th. So negative 2x to the 4th, or 2x squared, what I just wrote down, is now what I'm going to multiply by my original divisor, both of those things. So negative 2x squared times 2x squared is negative 4x to the 4th. So you'll notice that's always should be exactly the same term because we're going to subtract it away. Negative 2x squared times x, that's negative 2x cubed. And then we're going to subtract that away and see what's remaining of our dividend. So negative 4x to the 4th minus negative, so negative 4x to the 4th plus 4x to the 4th, those terms are gone. 0x cubed minus negative 2x cubed, so I'm really adding it. That ends up being 2x cubed, and then bring down the rest of this polynomial, 0x squared plus x plus 1. And then we continue the process. Repeat. 2x squared times what is 2x cubed? Well, that's just going to be x. Take that x, multiply it by our whole divisor, and then we'll subtract it out. So x times 2x squared is 2x cubed. X times x, positive x squared. We are going to subtract that away and see what's left. So the x cubed term is gone, and now we have 0x squared minus x squared. So we've got negative 1 x squared plus x plus 1. Are we finished yet? So we won't be finished until the degree of what's remaining of the divisor is less than the degree, or the dividend is less than the degree of the divisor. So this is x squared, this is squared, so I have one more round because this, I'm not done until this degree down here is smaller. So what do I multiply 2 by, 2x squared to get negative x squared? So well, to get 2 to 1, you would have to divide it by 2. And to get it to be negative, you would need a negative. So what do I multiply 2 by to get negative 1? That would be negative 1/2. And then x squared to x squared, we just leave it. So there's no x term here. Now I'm multiplying negative 1/2 by my whole divisor. Negative 1/2 times 2x squared is negative x squared. And then negative 1/2 times x is just minus 1/2 x. Subtract that whole thing away. So negative x squared minus negative or plus x squared, that's gone. I have x minus negative 1/2 of x. So really it's x plus 1/2 of x, which ends up being 1.5 x, or 3/2 x plus 1. Now the degree of what is remaining from my dividend is less than the degree of my divisor. That means I'm done with the long division. So my quotient we have up here, q of x is 3x cubed minus 2x squared plus x minus 1/2. And then my remainder down here, r of x, equals 3/2 x plus 1. So that is the long division process for polynomials. It's tedious and small errors happen all the time, especially with positives and negatives and just subtracting or adding the wrong way. So don't try and rush through this too much. But that's polynomial long division. I am going to show you a great shortcut called synthetic division that we can use when dividing polynomials by a certain type of polynomial. So synthetic division is basically picking up on the patterns from long division that are going to occur when you're dividing by something that's x minus c. In other words, just x plus or minus a number. I couldn't have used synthetic division on part B because we were dividing by 2x squared plus x. But if this had been like, if I was just dividing by x minus 4, then it's just simply x plus or minus a number. Then you can use synthetic division. In other words, if your divisor is linear, you can use synthetic division. So x minus a number. So if this, we've got a polynomial here divided by x minus 3. So this is linear and we can use synthetic division. So the c value, x minus c. So in this case, my c value is just 3. So you take your c value to set up the synthetic division. Take your c value, put it in a little box in the top left-hand corner of your workspace. Then what we're going to do is list out the coefficients of every x to a power in descending order. So the highest one is x cubed. So 5, the coefficient goes first. Then the coefficient of x squared. And if there was no x squared term, we would have to put a 0 there. So we're still accounting for those missing powers if there are any. So 5, negative 4, 6, and 11. So I've got a coefficient for every power of x cubed, x squared, x to the first, x to the 0. That's the setup, your c value, and then the coefficients. Then leave a space below because we're going to write in it, and we're going to draw a line underneath with a little bit of space to work right above it in between our top row. Synthetic division, once you have this set up, you're going to automatically, we just bring down that first term, 5. Then with the 5, we're going to multiply it by 3, so 15, and we put that right underneath the next number, 15. Now we're going to add those together. Emphasis on add, because up here we were subtracting. Here, synthetic division, combine them, just add them. Negative 15 and 4 is 11. And then I'm going to repeat the process. Take the 11 and multiply by 3. That's 33, and write it in the next blank under your next number. Combine them. 33 and 6 combines to 39. Repeat the process. 39 times 3 is 117. Put that under the next number. Combine them, 11 and 117. We've got 128. And then we're done. Put a bar here. So this last number is always going to be the remainder. These digits, 5, 11, and 39, those are the coefficients of your quotient. Then you just need to figure out the degree of your quotient. Well, if I had a 3rd degree polynomial and I divided out a 1st degree polynomial, my quotient should be degree 2. So if you're dividing by a first degree, this in synthetic division, your quotient is always going to be the degree that's 1 less than your original. So the degree of our quotient will be 2. So the quotient is, and then we just use our coefficients, 5, and we know this is a degree 2, so 5x squared. And then the rest of the terms go in descending order of powers of x. So plus 11x, plus 39, remainder 128. So a lot less writing than the polynomial long division, and a good useful shortcut when you're dividing by linear divisors. Let's do one more and then we'll practice both of these. So again, we're dividing 6n cubed, so we've got this whole cubic, and we're dividing by n plus 8, which is linear. So again, this is in the form of x minus c, but since it's plus 8, we have to think of it in the terms of n minus something. So that c value, if it's n plus 8, c is actually negative 8. So we set up the same way we did over here. Take your c value, put it in a little box in the top left corner, and then next to it, we're going to list out the coefficients of all of our variables in descending order, making sure we account for any missing ones. So 6n cubed, n squared is 47, n to the first is 2, and then 72. We list the coefficients, then draw a line, leaving a space because we're going to put some numbers in between. The first term is always just the same as your first coefficient. So we automatically bring the 6 down, and then we start that process of multiplying, add, multiplying, add. So 6 times 8 is negative 48. Put that under the next blank. Combine those two numbers. 47 plus negative 48 is negative 1. And repeat, negative 1 times negative 8 is positive 8. Put that in the next blank under the 2. Combine those two to get 10. Repeat, 10 times negative 8 is negative 80. Put that in the next blank under 72. Combine the two of them. We get negative 8. And then again, that last number, I always put this bar here. That is, so the end of my quotient is there. The last number is always the remainder. Since I started with a 3rd degree polynomial and divided out first degree, that means the result is 1 degree less. The quotient will be a quadratic. So the quotient is, I know the leading term is degree 2, and I know all the coefficients. So it's, oops, I guess it would be q of n, is 6n squared minus 1n plus 10, remainder r of x, negative 8. That's it. So synthetic division, much faster than long division, but again, you can only use it in these special cases where you're dividing by something in the form of x minus c. Okay, flip the page over, and we have 4 more division problems. So I'm going to do 2 of these, walk through with you, and then I'm going to have you guys pause the video and work through them on your own, and then resume the video to check your work. All right, so I'm actually going to jump down to do part F with you, since that one's a little more involved. So first of all, can we use synthetic division here when I'm dividing this numerator by that denominator? I cannot, because my divisor is not linear, it's quadratic. So this one, we have to go back to long division. So I'm going to set that up with my divisor over here, 2x squared minus 1. And then I'm putting my dividend. Notice that my dividend starts with a 5th degree, 8x to the 5th. So I need something for the 4th, so 2x to the 4th. I don't have an x cubed term in my dividend, so I need to represent that with 0x cubed and x squared. I don't have an x to the first term, so I need to put that in there, 0x to the first minus 8. So here's the setup. And then we start with the long division. So again, we're focusing on this leading term 2x squared. 2x squared times what? is negative 8x to the 5th. Well, that's going to be negative 4 to get 2 to negative 8, and then x squared times x cubed is x to the 5th. So that's going to be negative 4 x cubed, and I arrange that right above my 0x cubed just to stay organized. Then I take the negative 4x cubed and multiply it by the entire divisor. So negative 4x cubed times 2x squared is negative 8x to the 5th. And negative 4x cubed times negative 1 is positive 4x cubed. So this time, this is an example where Polydoku would be tricky to do here. So the negative 4x cubed times negative 1 being positive 4x cubed, we're going to put that underneath our x cubed term here. Draw that line, and we're going to subtract that away. So I have negative 8x to the 5th plus or minus negative, so plus. So the 8x to the 5th term is gone. Then I have 2x to the 4th minus, and I don't have anything to subtract, so that just comes down 2x to the 4th. And then 0 minus 4x cubed, so negative 4x cubed. And then I bring down the rest of this whole thing. So plus x squared plus 0x minus 8. And then we repeat the process. 2x squared times what is 2x to the 4th? Well, that's just going to be x squared. So I put that next over my x squared term. And then what do I do with the x squared? We multiply that by the entire divisor. So x squared times 2x squared is 2x to the 4th. X squared times negative 1 is negative x squared, but be careful, put that with your x squared term. And then we're going to draw this line and subtract this whole thing away to see what's remaining of our dividend. The x to the 4th terms are gone. Negative x cubed minus nothing is negative 4x cubed minus nothing is negative 4x cubed. And then I have x squared minus negative, so plus x squared, so 2x squared. And then bring down the rest, 0x minus 8. And continue because my dividend is still 3rd degree and my divisor is lower. So I want this degree to be lower, and then I'll be done. Okay, now we continue. 2x squared times what is negative 4x cubed. That's going to be negative 2. And then x squared times x is x cubed. So the next term here is negative 2x. Take the negative 2x, multiply by the entire divisor. So that's negative 4x cubed. And then negative 2x times negative 1 is positive 2x. So again, it goes over here under my x term. And we're going to subtract that away to see what's remaining. So the x cubed term is gone, negative 4x plus 4x. 2x squared minus nothing is 2x squared. And then I have 0x minus 2x, negative 2x. Bring down the rest, the minus 8. Okay, but now my degree is the same. I want this degree of the dividend to be less. So I have one more round of this. So 2x squared times what is 2x squared? That's just plus 1. And then we multiply 1 times 2x squared. 1 times negative 1, I'm putting that under the 8. And we subtract that whole thing away. So 2x squared minus 2x squared is gone. Negative 2x minus nothing is negative 2x. And negative 8 minus negative 1, so negative 8 plus 1 is negative 7. Now the degree of what's left of my dividend is less than the degree of my divisor. That means I have found the whole quotient, and whatever's down here is the remainder. So q of x is negative 4x cubed plus x squared minus 2x plus 1. And the remainder is negative 2x minus 7. Okay, and then I want to do one more with you guys. One more synthetic division. So we're actually just going to go to the left and do part E together. So part E, we have 3x to the 4th up top. I'm dividing by a linear polynomial. So that's in the form of x minus c. So this one we can use synthetic division. It'll save us a lot of time. So remember that this should be in the form of x minus c. So what I'm actually, that c value is -2. So we start by putting our -2 in a box in the left-hand corner, and then list coefficients of all of the x terms in descending order. So x to the 4th has coefficient of 3, but be careful here because there is no x cubed term. That means I have to account for that with a 0x cubed by putting a 0 for my next coefficient. If you skip that, the quotient will be incorrect. So it's important to use that 0 to represent my x cubed term. And then x squared has a coefficient of -7, and then 8, and then 2. So we list out the coefficients, leave a space below to write in the products that we're going to take here in a minute, and bring down our first term, which is always the same as our leading coefficient, 3. And then we start that multiplication and addition process. So 3 times -2 is -6. Put that in the next blank. Combine those two numbers, 0 plus -6 is -6. And repeat, -6 times -2 is +12. Put that in the next blank. And then combine -7 and 12, we get +5. Then repeat, 5 times -2 is -10. Combine those two, 8 minus 10 is -2. Repeat, 2 times -2 is +4. Combine 2 and 4, 6. Separate that out so you know your remainder is 6. So if my original dividend was degree 4 and I divided it by a linear, that means my quotient is 1 less than 4, which is 3rd degree or a cubic. So the quotient here, and then these are all my coefficients. So 3x cubed minus 6x squared plus 5x minus 2, remainder 6. So you guys are probably loving that synthetic division. It's much quicker, much cleaner looking. But again, you can only use it in these special cases. I just got a notification that my internet is unstable, so I'm sorry if that was choppy. So now you guys are going to try these two on your own. I'm going to stop recording. I want you to stop the video because I'm going to work through these and just show you them so that you can work through it on your own and then check your steps after if you're not correct. So take a second now, pause the video, I'll pause recording, and then you can resume the video when you're done working through these to check your work. Okay, so I've worked through these. So if you look at part C, check your quotient, 2x squared minus 3x plus 2, remainder -2x plus 9. If that is not what you got, pause again right now so you can check your steps with mine. Moving on to part D, I haven't totally completed it because I wanted to point out the fact that our coefficients up here, 1, 3, -13, -15, and then there's no constant at the end, which would just be +0. So that 0 still needs to go out here. Then once you continue with the synthetic division and you get this -15 and +15 here, 0 times 3 is 0. So your remainder is actually 0. So then since we started with a 4th degree polynomial, the quotient is a 3rd degree polynomial with these coefficients. So 1x cubed plus 6x squared plus 5x plus 0, so no constant. And the remainder is 0. That's kind of a special case because if the remainder is 0, there's nothing left over. What that means is x minus 3 is a factor of p of x if I can multiply it by another polynomial to get this exact p of x. So that's a special case we'll come back to. If that remainder is 0, obviously means it's a factor. So one last concept here is the remainder theorem, which is actually pretty cool. So if a polynomial is divided by, again, x minus c, a linear polynomial, then the remainder, if it's divided, is simply the same number that you get when you evaluate the function p by plugging in that c value. So what it means is if I take p of x and divide that by something and get a quotient, I'm dividing it by x minus c, then I'll get the quotient, q of x, and the remainder, instead of r of x, that remainder is actually just going to be our original polynomial evaluated at that c value. So let's apply that to this example because that's probably hard to wrap your mind around. So here's our polynomial p of x. So 5x to the fourth plus 7x cubed minus 8x squared plus 2x plus 1. If that's divided by x minus 2, what is the remainder? So find the remainder. We don't have to do the division. I know you can get the remainder by following through with the synthetic division, but you don't have to do that. You can just use the remainder theorem. So if our c value is -2, the remainder is going to be whatever I get when I just plug -2 in to this polynomial, p of -2. So you're going to, just grabbing your calculator, it'd be 5 times -2 to the fourth plus 7 times -2 cubed minus 8 times -2 squared plus 2 times -2 plus 1. So you're just crunching a bunch of numbers here. My advice to you when you're doing this using your calculator on a quiz or a test, just do it twice. It's very easy to miss key when you're typing in this many terms with all the exponents. So 5 times -2 to the fourth. Yep, see, way to go, miskeyed. Okay. Plus 7 times -2 cubed minus 8 times -2 squared plus 2 times -2 to the first plus 1. That's not right. What did I miskey? A perfect example. Plus -8. Where's my plus 1? Oh my gosh, I should be plugging in +2. What is wrong with me? Okay, hopefully you guys figured that out before I did. C is +2. I wish I could go back and re-record that part, but I'm not going to be able to because I don't feel like it. Okay, so let's do that again. So I am, again, I divided by x -2. So my C value is +2. Good job, Amy. Okay. So 5 times 2 to the fourth plus 7 times 2 cubed minus 8 times 2 squared plus 2 times 2 plus 1. 109. That's correct because I've checked that. Okay, so again, this is a perfect demonstration. Check your work. First of all, make sure you're plugging in the correct C value. Also, because it is easy to miskey, I would just do it twice on a test or quiz. Okay, so we know the remainder when p of x is divided by x -2 is 109. So we should be able to quickly answer, is d of x a factor of p of x? Is x -2 a factor of this polynomial? Well, considering it had a remainder, no, because r of x isn't 0. So if the remainder isn't 0, the divisor will not be a factor, just like with integers. Okay, let's do one more. So these are exactly the same. So use the remainder theorem. So again, I just want to reiterate, if I'm asking you to use the remainder theorem, I don't want you to do the division. I want you to use the remainder theorem. So p of x is this, d of x is x plus 2. Here is where my c value is -2. So I will plug in -2 to our original function p of x, and that's going to get me my remainder. So we're just going to plug it into our original polynomial. So x to the 6th, -2 to the 6th, plus 4 times negative 2 to the 5th minus 7 times negative 2 cubed plus 3 times negative 2 squared plus 17. Let's see if I typed all that. Of course I didn't. Of course I didn't type that in correctly. Squared plus 17, 21. So since we get 21 when I plug in, I know the remainder when p of x is divided by x plus 2, which also informs us of the fact that x plus 2 is not a factor of that. So you guys can try this last one and then on your own. I will tell you what the answer is, but then you probably won't do it. So try this one, see if x minus 3 is a factor of p of x or not. That's it. So we've got polynomial long division and synthetic division and the remainder theorem in this section. So you should be good to go on your homework, and I will see you next time.